and welcome to another episode of Beyond the Basics. This is episode 5, comparing integers. And honestly, yes, this is comparing integers, but it's also comparing all rational numbers, all positives, and all negatives. We're going to be looking at greater than, lesser than, opposite, absolute value, and then we're going to have some practices sprinkled there in between. So first of all, there's a couple of different models for doing greater than and less than. I'm going to use a vertical number line and then the temperature idea because most people understand temperature. There are tons of different ways to model greater than and less than, and these are only my two favorites because I found them to be the most effective with my students. First of all, the vertical number line. When you turn a vertical or a number line from this to this, the positives go on top, the negatives go down. And in our minds, that makes way more sense than left and right to most people. Especially if you were a student like me who got left and right mixed up. Then positives and negatives got confusing. I eventually understood that the positives went in order from reading right to left and negatives went backwards, but that took me a while to get. Looking at a vertical number line, you can see much easier. Because the greater numbers are literally above the other numbers. And all positives are greater than negatives. Your positives are all above 0, and your negatives are all below 0. If both numbers are negative, then the number that is above it on a vertical number line is greater. So in a vertical number line, a very common vertical number line is a thermometer, such as this one. Positive numbers go up, and negative numbers go down, especially on the Celsius side. This one doesn't go too far negative on the Fahrenheit side, but your Celsius side does. And it's a very common thing, so therefore most kids have seen a thermometer and recognize that when it goes warmer, the little mercury inside goes up, and when it gets colder, it goes down. Warm versus cool, this is the temperature idea. So basically we're combining vertical number line with the idea of warmer versus cooler. Because people understand that if I add fire to something, the temperature is going to go up. And if I add ice to something, the temperature is going to go down. So warmer is greater. So if you think of a number, the warmer temperature is greater than the cooler temperature, and the cooler temperature is lesser. So here's a little practice thing. We're going to start with an easy one, which one of these numbers is greater than 0 and which one is lesser than 0. 3. 3 is greater than 0 because it's positive. What about negative 3.1? That's lesser than 0 because it's negative. And negative 12? It's negative, so again, it's going to be less than 0. 42.67. It's positive, so it's greater than 0. What about 0? Is it greater than 0? No. Is it less than 0? No. I tricked you. It is equal to 0, so it is neither greater nor lesser, and neither is it positive or negative. Some people say, well, it's both positive and negative. Well, no, it's not. It's neither. It's like the fence line on a property. This side is Farmer Joe's, this side is Farmer Fred's, but the fence doesn't belong to either one, unless it belongs to the person who built it. But in this case, 0 doesn't belong to positive nor negative. 3/10. There's a 0 there. Is it 0? Is it neither? It's positive because it's greater than 0. Even if it's just a tiny bit greater than 0, it's greater than 0. Negative 3.5, not an integer, but still can be measured as less than 0 because it's negative. Now we're going to be doing something a little more complicated. Which one of these numbers is greater and which one is lesser? 3 compared to negative 134. Negative 134 is a big number. I mean, it's long. And 3 is just like 3. Which one's greater? Think about the other slide. 3 is actually greater because all positives are greater than all negatives. Or you could say it as any positive is greater than any negative, no matter how long the negative number is. Now, these are the ones that get a little bit more tricky. Negative 12 or negative 11. So in our brain, we're thinking, oh, 12 is bigger than 11. But this is negative. So this is where you can think of the vertical number line, or you can think of temperature. If it were minus 12 degrees at my house and minus 11 degrees at somebody else's house, Though it's not much, one of those numbers is warmer than the other one. Which is it? Negative 11 is slightly warmer than negative 12. And if you look at the vertical number line, negative 11 is slightly higher than negative 12, so it is greater. Negative 234.1 or 234.0. Well, if they were both positive, the negative 234.1 would be greater. But because that one is negative, the rule was all positives are greater than all negatives, or any positive is greater than any negative. So therefore, negative 234.0 is actually greater. So that's comparing the size of integers. Here's your notebook. Pause this part as needed to get your notebook copied. We're just adding to the rational numbers page that we did in episode 4. Now we're looking at the opposites. Positive is the opposite of negative. Up is the opposite of down. Left is the opposite of right. Before is the opposite of after. Above and below are opposites. And increase and decrease are opposites. There are a myriad of other opposites. The idea of an opposite is pretty straightforward. I mean, most people learn that at a very young age. So I'm not going to go too much into detail on this. We're just going to do some practice and see if you can pick it up. First idea is 30 feet less. What would the opposite be? 30 feet more. What about 30 feet above? What's the opposite? 30 feet below. What's the opposite of 5.7% more? 5.7% less. What's the opposite of 200 feet below sea level? 200 feet above sea level. What's the opposite of in the year 250 BC? In the year 250 AD. Negative 0.3 or negative 3/10. The opposite is positive 3/10. Opposite of positive 16 is negative 16. Here's your opposites notebook. On my notebook page, I was at the bottom of my page when I did the vertical number line in the warmer and the cooler. So now I just turned the page and went to the top of the next one. So here I was at the bottom. I simply turned the page and started at the top. If your notebook has more space at the bottom, feel free to use it. Pause as needed again to get these slides or to get your notes copied into your book. And those arrows in between the positives and negatives, negative 1 is not equal to positive 1. Negative 1's opposite is positive 1. So I did an arrow to show that what I started with and what I ended with, but they are not equal, so I cannot use an equal sign. Absolute value is something that a lot of people struggle with. They consider it an opposite, but it is not like opposite at all. Absolute value is a number's distance from 0, and distance is always positive. If I'm measuring something, a physical measurement, I will always get a positive number. Occasionally you'll see negative measurements in things like physics, but it's there to show a position, like before the starting or below a certain point, but actual distance is never negative. It's always positive. So a number's distance from 0 is also going to always be positive. You can also think of it as a number, how many, without regard to type. So like 3 negatives or 3 positives, I don't know, I just have 3 things, 3 items. There are symbols and there are 2 vertical lines around what you are going to find the absolute value of. So in this case, there are 2 vertical lines that surround the number 3. So what that is saying is the absolute value of 3. And then you read the equal sign as is. So the absolute value of 3 is 3. And what that's asking is how far is 3 from 0? So if I had a number line and you had 3 here and you had 0 here, or actually you would do 0 and then 3, it would be 3 steps between. So it is the distance of 3. Now we're going to go straight to the notebook. I am going to explain a few of these pictures as we go, but pause as you need to get it copied down. So absolute value is a number's distance from zero. It is always positive. The symbols are those two green lines, and I apologize for the smudge. I tried to erase and it didn't quite erase. And it is read as the absolute value of 3 is 3. If you consider a number line, the middle of every number line is 0. So what you're looking at the absolute value is how far is this number from the middle. So how far is 3 from 0? So as you can see here, I have my 0 and my 3, and there are 3 steps between the 0 and the 3. So the absolute value of 3 is 3. Consider negative 3. The absolute value of negative 3. Negative 3, and I forgot to put negative 3 on the number line. Oops. The distance between 0 and negative 3 is also 3 steps. It is 3 steps down, but absolute value doesn't matter if it's up or down. It's just how many. Its distance from 0 is 3. So the absolute value of negative 3 is also 3. Absolute value is always positive. Okay, so what about these? With these, the negative, or you have a negative outside the absolute value bars. Anything that is not in between those absolute value vertical bars is not included in the what is the absolute value of. So this first one is properly read as the negative absolute value of 3. Well, the absolute value of 3 is 3, as you can see. What's the negative absolute value of 3? It is negative 3. The negative sign outside the absolute value bars remains a part of your answer. And on the other one, the negative absolute value of negative 3, well, absolute value of negative 3 is 3. So the negative absolute value of negative 3 is still negative 3 because that negative is outside of your absolute value bars. Now here's some practice for absolute value. First one is the absolute value of negative 3 is... How far is negative 3 from 0? It is 3 spaces from 0, so therefore the answer is 3. And notice the answer does not have absolute value bars around it. We already found our absolute value at 3, so we don't need the absolute value bars anymore. What's the absolute value of 30? It is 30. So positive. Our absolute values are always positive. What's the absolute value of negative 30? It's also 30. What's the absolute value of 16? 16. So far you might notice that all of the answers are positive because the absolute value is positive. What's the absolute value of 5.7% more? More is a reference to a positive. So we kind of think about nothing, neither positive nor negative, so it's just 5.7%. What's the absolute value of 200 feet below sea level? Well, you're just talking about how many feet. So it's just 200 feet. So if you were in a boat and someone was 200 feet below sea level, they are 200 feet from you. If someone was like parasailing above you 200 feet, they are still 200 feet from the boat. What's the absolute value of the year 250 BC? It's just 250 years. Absolute value are written as positive. You're simply talking about a distance from 0. In these practices, I didn't do any that have a negative on the outside, but you'd have to be aware of those. Some of your practice pages will have negatives that are outside of your absolute value bars. Thanks for watching the video today. Please email me if you have any questions or leave some comments for me, and I will see you in the next video. In the next video, we're going to be talking about adding positives and adding negatives, setting things on fire and freezing them. Have a great day.